Hello again, here we are, number 57 of Unit 3, and I'm not given a picture, we're just given these coordinates, and we're asked to plot the coordinates, connect the points, see what we get, and then find the area and perimeter of whatever we have here. So let's plot these points and see what we got here. So -2, -3, there's the wrong tool. Okay, let's try that. Okay. Here's point A, -2, -3. B is -6, 5. C is at 11, 5. D is at 7, 2. And E is at 7, -3. Connecting the dots. We're going to get this, well, that's obviously not right. There you go. Get this irregular shaped object, so it's nothing specific, that we're used to, like a square, rectangular, or trapezoid or something, but it's a multitude of objects put together. And so I'm going to do the area first, and to do the area, I'm basically going to break it into a couple of different objects. I'm going to extend this line here, and so I'm going to have this trapezoid, and then this right triangle tacked on at the end. So I'm basically going to have two separate areas. This portion, we'll call it area 1, and then this large portion in the middle, we'll call it area 2. So to find the area, we need to find the area of section 1 plus the area of section 2. And section 1 is a triangle. It's a right triangle, so it's 1/2 base times height. And the base is 1, 2, 3, 4 units. And the height is 1, 2, 3 units. So 1/2 times 4 times 3 is 1/2 of 12, or 6. Okay, so we got that part. Now we just need to find the area of portion 2 here. Portion 2 is a trapezoid, so it's going to be 1/2 the sum of the bases. So let's count this out. Let's see, that's 7, and this is -6, so that's a total of 13. And here we're going from -2 to 7, so that's a total of 9. So 9 plus 13 is 22. And then the height, let's see, this is 5, and it's at -3, so it's a height of 8. So 1/2 22 times 8 is the same as 11 times 8, which is 88. Or 4 times 22, right? So the total area is 6 plus 88, which is 94 square units. Okay, now for the perimeter, we need to add all the sides together. Well, we already have this part, which is 9. This portion here, we're going from -3 to 2, so that's 5. This part right here was 13, and this part was 1, 2, 3, 4. So we have 13 plus 9 plus 5 plus 4, plus there's these two diagonal sections. And now those diagonal sections we're going to have to find by using the Pythagorean theorem. So I'm going to create this other right triangle here. Let's see if we can't figure out what those are. Let's see, this length is 3, and that's 4, so I know this is a 3, 4, 5 right triangle. So we could do Pythagorean theorem, 2 squared plus 4 squared, which is 9 plus 16, which is 25. Square root of 25 is 5. So that one's pretty straightforward. This one, let's see what we have here. from -3 to 5, that's a distance of 8. And this is 1, 2, 3, 4. Okay. So we have to figure out this diagonal length here. So Pythagorean theorem says 4 squared plus 8 squared equals 6 squared, 16 plus 64 equals c squared, 80 equals c squared. So that's the square root of 80, which 80 reduces. It doesn't have a perfect square root, but it will reduce. We can use our tricks there to help reduce that. This is going to be 4 root 3. Let's see, 16 times 5? Yeah, so 16 times 5. So the square root of 80 equals the square root of 16 times 5, which is 4 root 5. Now we just got to add all this together. The problem we run into is these numbers we can add together fine. We can do 13 plus 9 plus 5 plus 4 plus 5. When we get to this part, we can't smush those two together. So I'll explain that when we get there. We'll hold this up for a little bit. So 13 plus 9 is 22, plus another 10 there is 32, plus 4 is 36, so 36 plus 4 root 5. And that's it. This is all we can do. There's no way you can combine a number like 36 and a radical of 5. It's like trying to take an expression and smush together, x's and y's. You can't say, 3x plus 3y is 3xy. You can't smush those together. Same thing here. These are different types of numbers. So here we have this, irrational square root of 5, and here we have this rational number 36. We can't smush them together and make one big thing. If this was in terms of root 5s, and this other term was in terms of root 5s, then yes, you can smush them together. But in this case, we're stuck with just 36 plus 4 root 5. That's as simplified as we can get. Okay, and then there's our area up here. Okay, any questions or comments about how we drew that out, found those lengths? Feel free to leave a question or comment.